Okay, Math 1 kids, welcome to day 2 of Module 6. Today we're just going to be talking about slope-intercept form. Which is y equals mx plus b. So we're saying whatever multiplies x, this is our rate of change. And whatever's added onto it, this is the y-intercept. And I just want us to become familiar with the parts of equations so that we can move seamlessly between equations and intercepts and graphs and rates of change. To do that, we're going to take a couple of examples. First, make a table of values. So we can pick whatever x values we want. But 0 is a good one to start with. 0, remember, that's going to find our y-intercept. Y-intercept x equals 0. So when x equals 0, that means we're going to have 0 times 1/2 minus 3. Minus 3. Now, what values of x are going to make this easy to calculate? If I put 3 in here, then I'd be 3 times 1/2. 3 times 1/2 is 3 halves minus 3. I'm dealing with fractions, yuck. So let's figure out how not to deal with fractions. Look that since I'm going to be multiplying by 1/2, if I do multiples of 2, it's going to make it a lot easier myself. So this is 2 times 1/2 minus 3, which equals 1 minus 3, or negative 2. 4, right? This is going to be 4, half of 4 is 2 minus 3 is negative 1. 6 is going to be, half of that is 3 minus 3 is 0. If we keep going up by 2, you'll see that, look, this is 0 minus 3, 1 minus 3, 2 minus 3. So half of 8 is 4, half of 10 is 5. So what do we notice our rate of change is? Well, we've got change in, this is, we can pick any 2 points, right? Any 2 y points and any 2 x points. I kind of like negative numbers, so I'm going to do these. 1 minus 0 and 8 minus 6. So this is 1/2. Our rate of change is 1/2. In words, this means x is going, not x, right? Y is going up by 1 for every 2x. We don't know what x and y stand for in this case, but we can know that whatever y stands for, that's going to be going up by 1 for every 2. And the y-intercept is right here. Negative 3. So this means when x is 0, y is negative 3. Look how we can put this on a graph. Here's 0, here's negative 3. So when x is 0, then we've got 2, negative 2, and 4, negative 1. Oops. There we are, 4, negative 1. And 6, 0. So we can see that it's going in a straight line. We could graph it like this. Since we don't have any context, we don't know if it's discrete. We can assume it's continuous. Okay. Another way of doing doing this, look, we say y is going up by 1. up by 1 for every $2x, right? Plus 2x. So I want you to use a similar process for this one. Notice that it's negative. So don't forget that negative. That means that your rate of change, one of them is going to be negative. But we can plug our values in for x. Notice that multiples of 2 came out nice and round numbers. How about 3? Try that. Okay. So finish this. When you're done with that, I want you to consider this. What were the easiest values in the table to calculate in terms of 4x? Okay, and then how does that relate to the rate of change? In other words, how can we pick easy values? That's what we're looking for. All right. Example 2, what is the y-intercept? Well, it's a little hard to read here, but this is -2 and -4. So the y-intercept we can see right there, it is 0, 2. We can find 2 points. I'm looking at a point here and a point here. This is the point -4, 3, and the point 0, 2. We could also do the point 4, 1. So I'm going to pick just 2 of them, but we'll do -4, 3, and 4, 1. Calculate the rate of change. So remember, we have a easier time if we put it into a table like this, and then we say this is 3 minus 1 over -4 minus 4, 2 over -8. This is -1/4. Okay. So what is the equation? Y equals m, there's the rate of change, x plus b, y-intercept. So that means our slope, our rate of change, this is m, and this is b. So we're saying that our equation is y equals -1/4 x plus 2. And that's the equation for this line. Okay. One more example to use. Use the following equation to fill in the blanks for the context. So here's the equation we're going to use. We're saying what is happening. A submarine is something at a constant rate of something meters for every something. Okay, so we need to know, is this increasing or decreasing? This should be a number. And this should be number and word. Okay. And then your challenge then is to figure out when would the submarine reach the level. If you can figure out what x represents here and what f of x represents, then we can say, well, which one of these is going to tell us what it means to reach the surface? So, and I'll give you a hint, one of them is going to have to equal 0, right? We're talking about the depth. Right? So that's the notes for today, and I encourage you to work with each other to fill that out, and then you can work on completing the homework.